Hello everyone. Welcome to yet another interesting session on collections in Java. Today we are going to dive deeper into the list interface in Java and its hands-on implementation. But before we begin, make sure to follow our YouTube channel and hit the bell icon to never miss an update from Intellipaat. First of all, let's look into the agenda for today's session. We will begin this session by understanding details about list interface in Java. Next, we'll look into the theoretical and implementation details of Arraylist class. After that, we'll look into the intricacies of linked list class. Finally, we'll understand vector and stack class in collection framework hierarchy. I hope I have made myself clear with the agenda. So without wasting any time, let's get started with our first topic, list interface in Java. So without any further ado, let's get started with our first topic, list interface in Java. List interface in Java provides a way to store the elements in an ordered manner. It extends the collection class and most importantly supports the redundancy, which simply means that the duplicate elements can be added into the list classes. The list interface allows its features or classes to maintain the insertion order. Hence, index or positional approach is achievable for all the child classes. You can find the list interface in java.util package and it contains the list iterator method through which we can iterate the list in both forward and backward directions. The classes that implement list interface are Arraylist, linked list, vector, and stack. With this session, we'll discuss and implement all these classes one by one. Let's begin with Arraylist. The Arraylist is an implementation of a list that can dynamically add or remove elements. The data which is added into the Arraylist is most often added in an index format. This particular type of list almost behaves like an array, except the fact that it is dynamic and its size can be reduced or increased during any instance of time. This feature of Arraylist makes it much more flexible than the traditional arrays. Let's look into few properties of Arraylist class. The first property we have on our list is that the Java Arraylist class supports the insertion of duplicate elements, which we have seen previously. Also, the Java Arraylist class maintains the insertion order and it is completely non-synchronized, which means it is not thread safe. Java Arraylist allows random access too, as it works on index basis. The next important property conveys that in Arraylist, manipulation is little bit slower than the linked list in Java because a lot of shifting needs to happen if any element is removed from the Arraylist. Consider the example of deletion from the middle. Here, let's say we want to delete element with value 21 which is available at the middle of Arraylist. Now, once we delete this element, the empty space will get created and the elements after 21 must be shifted because Arraylist stores elements in consecutive positions. Now for that matter, IDE will have to implement multiple shiftings, which makes the complexity of this operation big of n square, and hence the manipulation operation will become quite slower. Then we have another property which says we cannot create an array list of the primitive types such as integer, float, char, etc. We'll have to use the predefined wrapper classes in such cases. So the example given here won't be the right option for creating an array list, but if you write it with wrapper class, then it will work fine. I hope this is clear to all of you. The next property we have on our list says that Java ArrayList gets initialized by the size. The size is dynamic in the ArrayList, which varies according to the elements getting added or removed from the list. The syntax for creating this ArrayList with generic type is ArrayList, then the object name equal to new ArrayList. You can use more specified wrappers to gather elements of the same data type as well, like we have seen previously. The methods that you get with Arraylist class are shown on the screen. You don't have to customize any function. With just a function call, you can perform any type of operations on an array list, which is the basic advantage of collection framework hierarchy. Having said that, let's move to the code editor and implement the Arraylist program. Okay guys, so let's create the file for this program. We will name it as first Arraylist program.java. Let's press enter. So the class will get created for us. Then we'll also have to import java.util library. So we'll do that here. Import java.util star. Now inside the first ArrayList program class, we'll create our static void method. that is main method. So public static void main, and inside it string args. Now the first thing that we will do is we'll create the object of an array list. So what we'll have to do is we'll have to write array list, then type of wrapper class. So we'll be using string wrapper class here, string, then the name of object, we'll name it as lst equal to new array list and the wrapper class semicolon. Now the next step we'll do is we'll add few elements into this array list. So add a comment inserting elements into the array list. So the syntax for adding element will be lst dot add function and the name of object that you want to add. So let's say the first will be Intellipaat. We'll copy this and we'll paste few times. Now let's rename these objects. Anyway, if we want to Intellipaat twice or thrice time, it's possible because Arraylist allows duplicate elements. So we don't have to worry about that. So we'll keep one more Intellipaat object. Then we'll change Java collections list and Arraylist. Now what will happen if we try to add an integer element to this list? Let's try out. So if you can see this terminal, it's already prompting the error. The method add int string in the type Arraylist, which means we cannot add the integer type into our array list. So we'll comment it and we'll run this operation. But before that, we'll print our list. List T. And let's run this program. So if you guys can see, we are getting our list here. Intellipaat, Java collections, list and array list. So I hope this first operation is clear to all of you. Now let's move to the next operation, which will be accessing the object from an array list. So let's add comment about that too. Accessing the array list. Now we have a get function for that, so we'll make use of it. So first we'll write system dot out dot println. So what we are going to do, we are going to access the element from the second index, the element available at second index will be plus lst dot get the index number, which will be 2, and we'll add semicolon again. And let's run this and see if it is giving us the element present at second index. Yeah, the element available at second index is Java. You can see that here as well. So let's move to the next part, which is updating the object of Arraylist. So how we are going to do that? So to do that, we have a function named set. So we'll make use of it. So how we can do that? lst dot set function, and then we'll add the index and then comma, and then we'll change the Java with element named as let's say programming, add semicolon, and then we'll print the updated element, print lst dot get 2 system dot out. Let's run this and see if it is working fine or not. See guys, the element has been updated. The word that we are getting at index 2 is programming. I hope this operation is also clear to all of you. Now let's move to the another operation, that is removing elements from an array list. To do that, we have remove function in Arraylist class. So let's make use of it. lst dot remove the index position. So let's remove element present at 0th position. Then we'll remove lst dot remove element present at second location. Now let's print our list and see if those elements are removed from it or not. Now as you can see, there were 6 elements previously and now there are only 4 elements. So 2 elements has been removed. Then let's move to the final operation that we have here, that is iterating the array list using Iterator method. So let's add a title about that, iterating the array list. For that, we are going to require the iterator function, which is part of iterator class. So we'll have to invoke it. So iterator itr object name equal to lst dot iterator and semicolon. Now we'll add while function. Itr object has the next element in a list, while iterator has the next element, what we'll do is we'll print that element. So for that we'll add system.out.println command and we will print itr.next. I hope this is clear to all of you. Now let's run this operation and see if it is working fine or not. Yeah, you can see that all the 4 objects has been printed here one by one. So I hope all this implementation program is clear to all of you guys. Now let's move to the next section in our agenda. Moving ahead, we'll explore the linked list class of Java collection framework. Linked list class in collection framework extend list and collection interface and is part of java.util package. As its name portrays, the linked list class is an implementation of linked list data structure where the elements are not stored in contiguous location and every element is a separate object with a data part and address part. All the elements are linked using node structures. A node is basically a structure or a blend of two fields, a data field and an address field. The data field stores the element value, whereas an address field stores the pointer or reference to the next item in a list. Due to the dynamicity and ease of insertion and deletions, linked list is preferred over arrays. However, it has a few disadvantages too, such as the nodes cannot be accessed directly. Instead, we need to start from the head and follow through the links to reach a node we wish to access. For instance, consider this linked list and suppose that we want to reach the tail node. To do so, we'll have to begin from the head node and then traverse our way towards the tail. This implies that the complexity to access the nth element will be big of n. Then another point I want you guys to note is that this class has been created by using doubly linked list data structure. Thus, we can traverse it easily in both backward and forward directions. To create the linked list object, you'll just have to use the linked list constructor. The syntax for same is linked list then object type equal to new linked list object type, where we'll have to add object name as well. Now let's have a look at different inbuilt methods available for the linked list class. We have methods named add, add all, add first, add last, clone, get, list iterator and many more. In the next phase, we'll implement and perform a few operations on linked list with the methods that we just listed in last slide. So let's visit the code editor. So let's create a new file to implement the linked list program. We'll name it as first linked list program .java. So the class has been created. Now what we have to do is we'll have to import java.util library .util.star and semicolon. Now the next step will be adding the public static void main method. So we'll do that public static void main and inside it we'll pass string args as an argument. Now the first thing we'll do is we'll clear our terminal. So we'll use clear command for that. Okay, so now it's clear. So let's get started with creating the linked list object. So first step to do that will be calling the linked list class and then giving it a wrapper class. So this time we'll make it as integer object and then the name of an object. So we'll name it as LL, which is short form for linked list, new linked list and then wrapper class integer and semicolon. Now the first operation that we'll do is insertion. So we'll add comment about that. Now again, to insert element into linked list, we are going to use add function. So let's add few elements. ll.add 10, 42, 12, 34, 9, 10 and 21. Okay, now let's print our linked list and see if all the elements have been inserted or not. So we'll use system.out.println command to do that and inside it we'll pass the object name and semicolon. So let's run our program and see if all the elements are inserted or not. Here you can see that all the elements have been inserted. Now the next operation that we are going to do is the traversal of this linked list, and to do that we are again going to use Iterator method. So let's use the Iterator class. To generate the Iterator method, we'll have to add the wrapper class as well, which is integer in this case. Now next what we'll do is we'll create the object of this Iterator class named as itr, and then we'll add Iterator functionality to our linked list object using Iterator method. Now we'll use while loop to iterate the list while itr dot has next. We will print the element. Now let's run our code and see if it is working or not. So see, all the elements are getting iterated and printed one by one. That means this function also works fine. Now let's do next operation, that is removing the elements from linked list. To do that, we have function named remove. So we'll add ll.remove command, which will remove the object from given location. So first we'll delete the location 0, then we will remove the location 4. Now let's see if these elements are getting removed from our list or not. System dot out dot print ln ll, and run the code. If you can see, the 2 elements have been removed from our linked list. So let's move to the next functionality, which is accessing the element from linked list access. And to access the element, we have get function. So we'll use it inside the printing statement command out.println the element at index 1 its, and we'll use ll dot get element from index 1. Now let's run it and check if this is working or not. Oh, okay. So semicolon must be added after the ending parenthesis. See, the element at index 1 is 12. So this is also working fine. Now finally, we will remove all the elements from our linked list. So for that we have the function named as clear function for removing all linked list elements. So the only command we'll have to use is ll.clear, and it will remove all the elements from our linked list. So let's print our linked list to see if all the elements are removed or not. Yeah, here you can see that all the elements have been removed and we have received the null linked list object. So I hope this implementation is clear to all of you guys. Let's move to the next section and learn more about it. Vector class is yet another class that extends the list interface in collection hierarchy. Vector class in Java implements array-like structure which can grow in its size to insert n number of items. It behaves just like Arraylist. You can access the elements of a vector by using their respective indexes, just like Arraylist does. The only difference between both these classes is that Arraylist is non-synchronized, whereas Vector is completely synchronized. Because of this distinctive feature of a vector, you can expect a poor performance while adding, searching, deleting and updating its elements. However, there is also one positive side of this synchronization. It makes this data structure thread safe. Thread safety simply means that only one thread can work on a vector at a time, and the rest of all threads cannot perform other operations on it until the first thread releases its lock. Let's discover the different ways to construct the vector class. First and easiest way to construct the vector is very simple. We'll just have to create a new object of the vector class. However, this will create a vector with the initial capacity of 10 elements. But don't worry about that, cause if you insert the 11th element, the capacity will automatically get doubled. The next way to initialize vector is providing the custom vector size. It goes like vector with data wrapper type, object name equal to new vector, and inside curly braces will pass the size parameter. The third initialization method allows us to provide both custom size and incrementation size. This method of initialization will specify the number of elements to allocate each time a vector is resized upward the set limit, which is done using the increment operator. The fourth method to construct the vector allows us to create a vector that will store the elements of some other collection. So here we'll pass collection C as an argument. Here are a few important built-in vector class methods that you can use to perform multiple manipulation operations. Try to remember these operations cause in the next section we'll create and perform a few operations on vector data structure. So let's visit the code editor for that. Okay guys, let's first create the new file for implementing the vector program. So we'll name it as first vector program dot java. This will create the public class for us. However, we'll have to import java.util library, import java.util dot star semicolon. Now the next step will be creating the static main method. So we'll do that. Public static void main string args. Inside this method, we'll first create our vector object, and to do that, the command we have is vector, then the object type. We are going to use string object here. So string, then the name of object, then new vector and the object type. Now that the object has been created, so we'll add few elements into it. To do that, we are going to use two methods, which is add and add element. So first we'll use add method to insert few elements. We dot add java programming, and now we'll add few elements using add element method. Now that we have added few elements, we'll print our vector. So to do that, we'll use system.out.println method, and inside it we'll pass our object v. So let's run our code and see if the vector is getting created or not. So if you can see here, the vector is getting created and all the elements are also getting inserted into it. So with this, let's move to the next operation, that is finding element inside the vector. And to do that, we have function named as element add. So let's see how we can use this function to extract an element from specified location. System.out.println accessing element at location 3. Now we will use the element at method, and inside it we'll pass the index, which is 3 in this case. Now let's see what output this command brings. So see, here you can see that the element at index 3 is Java. Now let's move to the next operation in our list, which is removal of elements. So we'll remove few elements using the remove function. So let's make a call to remove function and pass index to it, v.remove. Now let's print our vector after that. Yeah, here you can see that two objects have been deleted from our vector list. So let's move to the next operation on our list, which is traversal of vector. To achieve this traversal, we are going to use Iterator method. So for that, we'll have to make a call to Iterator class, then the object type, which will be string, equal to itr v dot iterator function and semicolon. Now we will use while to traverse the vector, and inside it we'll pass itr dot has next. Then if it has the next element, we'll print that element. System dot out dot print ln v itr dot next. Now let's run this code. See, here all the objects are getting printed one by one, which means the traversal is working fine. I wish that this hands-on demo part is clear to all of you guys, because moving forward we'll discover the last class of list interface known as stack. The stack class implements the vector class and extends the list interface of Java collection framework. As the name suggests, this class models and implements stack data structure. The form data container with this class will follow last in, first out or LIFO principle, which simply means that the element which inserted at last will leave the stack data container at first. To better understand this statement, let's consider the example of book stack. In a stack of book, we can only place a new book on this book stack from the top side, right? Also, you cannot remove the book from the bottom. You'll have to remove the books from the top side itself, which simply indicates that the book that is placed on top at last will be removed first, and the book that was inserted at first in the stack will definitely get removed at last. This same scenario remains true for stack data structure. Stack class only contains default constructor. You can construct a new object of stack using the statement stack type of object, then object name equal to new stack, and then again object type. The built-in methods for stack class are given on the screen. Moving forward, by using some of these methods, we'll create the stack data container and perform some operations on it. So let's visit the code editor to do that. Okay guys, so let's create a new file to create the stack data structure. We'll name this file as first stack program.java. Let's hit enter. It will create the public class. But prior to this, we'll have to add java.util library. So we'll add command import java.util.star and semicolon. Now inside the first stack program class, we'll create the main method. So public static void main string args. Now let's create the stack object. Stack, the object type will be integer and the object name will be stk equal to new stack with integer type. This command will create the stack object. Now the first thing we are going to do is inserting few elements into the stack. So the function we have for that is push. So we'll use that function stk.push 78 stk.push 78. We'll copy this command and paste it few times. Now we can change the items 112, 43, 24 and so on. So now let's check if the elements have been added into the stack or not. To do that, we'll print our stack using system.out.println method. Now let's run our program. See, the stack has been created. Now the first thing we'll do is we will remove few elements, and to do that we are going to use pop operation. So basically it will remove the element present at top. So the first element that should be deleted is 78 and then 24. So we'll perform this operation twice and see if those elements are getting removed or not. So stack.pop twice. And again we'll print the state of our stack using println method. Here you can see that the top elements have been removed, which is 78 and 24. Now the next operation we have is searching for an element in stack. So let's add comment for that. So the function we have for this purpose is named as search. So let's see how we can use this function. System.out.println searching element with value 112 inside, and now we'll give call to our search function stk.search the object which is 112 and semicolon. Now once we run this program, we'll see position of 112 which is at index 2. Now let's move to the next operation. The next operation we have is finding out the topmost element in stack, and to do this operation we have method named peek, which simply returns the element present at the topmost location. So let's see how this operation can be done. So we'll print system dot out dot println the element at topmost position is plus stk dot peak. Let's see if this returns the topmost element, which is 43 in our case. See here, it's returning the value 43, right? So let's move to the next operation, which is removing all the elements from stack. So for that we have function named clear. So once we make a call, all the elements inside stack will get automatically removed. So let's print the state of our stack to see if all the elements have been removed or not. Here you can see that the state of stack is empty. I hope this programming interpretation of stack is clear to all of you guys. That's all we have for this session. Thank you so much for being here till the end of this extensive tutorial. I wish you all the very best, and also do subscribe to our channel to get interesting digital technology updates from us.
Just a quick info, guys. Intellipaat provides Java certification online training, mentored by industry experts, the course link of which is given in the description below.